Right. Well, let's go ahead and get started. This is the roll sheet of today, so make sure you put your name next to, write your name next to the printed name on the roll sheet. Just want to see, how many people are actually still in the class. According to the roster, I still have 35, but this does not feel like 35 students. I think I have a. This looks like about 20 to me, so it's off by a lot. All right. Are there any questions about the exam?
Is it in the lab or is it on the paper?
Very good question. It will be in the lab. Okay, so the first thing is, we will be taking the second exam in the lab. So the way the exam is going to be carried out will be about the same as the homework assignment. You download the file. Sheet 1 will have the pseudocode. Sheet 2 will have your trace. And then when you're all done, you have to save the file and then upload the file to Moodle. The upload interface will be about the same. I can just make up one quick test so they can see what it looks like. And that's pretty much it. You have 4 questions, similar to the 4 questions that you saw on Tuesday. And you have 80 minutes exactly to do it. In this case, Moodle is the one that will enforce the time limit. Because after the certain time, Moodle will just shut off and turn off the upload interface, so there will be no way to upload the file after. I will give you guys up to 11:50, which is the end of this class. Okay, so first thing first, where is the lab? Because I'm pretty sure not everybody has been to the lab, because we have not. This is not a class with a lab component. So what we'll do is we'll borrow Google Map to take a look at our campus. And we'll use the satellite picture. This is great. I mean, this is just excellent. All right, so let's go ahead and take a look at this picture here. Probably we want to turn off the 45 degrees, so it's a view from the top, just that. And let's maximize that. All right. This is where we are right now. Okay, this is room 121, which is here, and there's a boat fountain. If you walk outside and turn left, you should see a boat fountain already, and room 152 is right here. Is that okay?
So you just want us to meet over there?
Yeah. So next Tuesday, we'll meet over there at 10:30. The test will start at 10:30, so you might want to get there by 10:20 or so. So that will give you like about 5 to 10 minutes. You can settle down. Log into Moodle, open up all the documents that you think will be relevant, and just kind of let yourself rest a little bit before the test starts. Okay. How many people have been using room 152 since the beginning of this semester for one class or another? So you guys will be fine, but the rest of the class, you will need to first register for an account in that lab. Okay, so you don't want to wait until next Tuesday to do that. You want to do it like today. Okay, right after this class, just head out to room 152. When you walk in there, there will be a counter on the right hand side. Just go to the technicians or the lab techs in that lab and just tell them that you will need to use those computers next Tuesday. Yep.
Do we need to register again if we registered another semester?
Yes, you do. It is on a per semester basis. So you will have to register again, which is very simple. All you have to do is to give those people your student ID card. If you don't have your student ID card, then you will have to remember your student ID, plus you will also have to have a picture ID with you when you register. Okay, if you have a student ID, it's easy because it has your picture. It also has a barcode, and they will scan your barcode into the system. They will check that you are in one of the classes that we offer, and then after that they will give you a yellow sheet of paper to sign. The yellow sheet of paper, the only purpose is for accounting purposes, so that when you use computers in the lab, hopefully the college will get some money back from the state government. So it's for accounting purposes only. When you go to the computer for the first time, I think you can log in using your email address, which is the same email address or the same password and the same account name that you use throughout the entire district. So are there any questions? But you definitely don't want to wait until next Tuesday to register. If you can do it today, just get it done. So next Tuesday, you can walk into the lab, just go to a workstation, and be able to log in. The worst thing that can happen is for a whole bunch of people, like 20-something people, to show up on next Tuesday exactly at 10:30, okay, and they have to line up to wait for the registration and all that stuff. Then those people will be wasting like 5 to 10 minutes for just no reason at all. So are there any questions regarding the registration process or where that lab is located? No questions? You guys understand, the relative location of the lab to this classroom? Yes?
Yes.
Okay, excellent. Okay, so just remember it's to the south of the boat fountain, and it's room 152. We will use section C. Okay, we'll fill up section C first, and then we'll fill up section B, or the part of section B that is right next to section C. So those are the two sections that we'll be using. Do not use section A. Section A will remain as an open section. Are there any questions about where we're going to take the test? No?
I think you haven't uploaded Tuesday's files to Moodle.
I have not? Okay, I can upload it today. Several more things. The lab can be a little bit noisy at times, because it is a general lab. It is not, a lab just for taking, tests or assessments. So it can be a little bit, noisy. If you do not like distractions, do not use, your headphone. I know the earbuds are relatively effective, but you can get, those earplugs, for lawn mowing and stuff like that. That's fine. I just don't want people to have something attached to their iPod or their iPhone during the test. So that's the only concern. If you do not have an ear muff like that, that is very effective. They sell those things at Harbor Freight for $3 or $4. Okay, they're big, red, kind of ear muff thing. They work really well. I own several of those things. When I do lawn mowing and other things that are noisy, or when the kids are noisy, I wear those things too. So they can help you isolate, all the noise from the surrounding, so that you can concentrate more on the test. I just want to give you guys that warning because some people feel that it's very distracting when other people are talking in the lab, and some people do not seem to mind at all. So it's entirely up to you to see how easily you get distracted by other people, just walking and talking around you. Any questions about that part? Because I want all cell phones, iPods, Wii's and not Wii's, DS, and whatnot, turned off and kept away during the test. Is that okay? Now you can also bring your own flash drives. So if you have prepared material yourself for the test, like a condensation of all the notes, everything that we have talked about, or you have your own way of organizing all the sample programs and whatnot, you can bring your own flash drive. Okay. And you can look at your own documents, during the test. There's nothing wrong with that. If you want to use Google, you can use Google. I don't think Google is going to be very helpful in this case, just because the way I teach this class is very unique. So, when you look up material on how to trace a subroutine, I don't think Google can be very helpful in that case. Yep.
You can bring paper notes.
Yes, you can print. You can bring paper notes or paper-based notes that is either handwritten or printed prior to the test. Okay. Any other questions? How many people have a portable installation of OpenOffice? Okay, I will bring that too, because you will have your own settings, like all the autocorrect features, turned off or turned on, already. So that way you are using an installation that you are very familiar with instead of the stock installation at the lab. Any other questions? Yep.
So there's going to be like 4 files that we'll have to download and then
Right.
save. Okay.
Yep. Each question. Well, I can do it either way. I can give you one single zip file, so you don't have to download it individually, but you will still have to upload individually, so that I can tell which file is the answer of which question. So which way do you guys prefer? Do you prefer just say it again?
Like the homework.
Like the homework, one file per question. So that way it's less confusing. I think it's less confusing. I also recommend that you bring your own flash drive so that you can save the document onto your own flash drive. We talked about that on Tuesday already. Because just in case it's not just one application crashing. If your computer crashes altogether and you cannot continue to use a workstation, if you have been saving your work on your own thumb drive or your flash drive, you can just take it to the next computer, and Moodle allows you to continue the test that way. So that would be a good way to do it. You also want to save your documents frequently. Okay, not upload it to Moodle, but save it onto your own thumb drive, frequently, just in case the program crashes or anything like that happens. You don't want to lose all the things that you have done in the past 15 minutes. Okay, maybe the past 30 seconds or maybe the past minute or so would be okay, but you don't want to lose any more than that. Yep.
When we submit them, are we going to submit it just like the homework assignment?
Yes.
Or are there going to be 4 different ones, and we'll just upload them back?
Each one will have its own upload interface. Yeah. I'll show you guys exactly how it looks like. So let me give you a kind of just a sample of what it looks like. Now remember, all iPod and iPhone devices will have to be turned off and kept away from the desk during the test. So if you have all the notes downloaded onto your iPhone or your iPod, you will have to extract it out onto a regular thumb drive before you can use it during the test. I think in the lab, all the computers are like this one. It already has a multi-card reader thing. If you have SD cards or something like that, you can plug right in, and you don't need a regular USB thumb drive. Okay, so what I'll do is I'm just making a test right now, just for the purpose of demonstrating what it looks like. So we'll just say this is exam 2 demonstration. And obviously for this one, I don't need to open or close the quiz. And I'll go ahead and put a time limit here, just so that you can see where the timer will appear. It will appear on the title bar. So I'll just put 80 minutes here, which is what you will have also on next Tuesday. Thank you. And in this case, I will only display one question per page, so that way it's less confusing. You cannot be downloading one file and uploading to another question. And okay, I think that should be it. Save and display. I'm creating a question on the fly, so this is just a demo question. And the question is going to look exactly like this. Download this file, trace it in sheet 2, and upload finished document. And you also have to use OpenOffice. You cannot use Microsoft Excel for this homework for this exam. And I'm just going to link it to a particular document. It doesn't matter which one. Just link it to this one. Okay. So now I have a test that has one single question, and that's enough for the purpose of the demonstration. So now I'll go back to the top part here. I have to switch to a student role just so that you can see exactly what you will be seeing on Tuesday. And here we have exam 2 demo. and it will warn you that you can only have one single attempt, because you cannot come back. After you hit submit all and finish, you cannot come back and say, oh, I want to change my answer, or I want to upload another file to this question. You cannot do that once you click that button. Okay, this is what you will see. Obviously, I only have one question in this case, and you will see 4. When you have 4 questions instead of 1, there will be a link to the other 3 questions. If you specify a file to upload and then click another question, it will automatically upload that file. Okay, so, yep, go ahead.
Are you going to be able to do, instead of, like, if I don't like the first one first?
Yeah, you can change the order. Yes, you do not have to answer the questions the way, in the same order it is presented. So if you look at the question and go, okay, this one is going to take me a lot more time, you can switch to the next one. You just have to remember, which file to upload to which question. That's the only part that you have to pay attention to. I have had people to turn in the same file to 2 different questions. So, so one of the questions is lost, or the answer to one of the questions would be lost in that case. Okay, so it's the same, same approach. There are 2 buttons here, and if you look at the title bar, also down here, it will display how much time is remaining, which is going to be helpful because you do want to keep an eye on how much time is remaining. The 4 questions will carry the same amount of points. Okay, so if you feel that one is easier, go for that one first. Okay, definitely prioritize and don't waste time on something that you think is going to is going to take a long time. And then the second thing is you want to look at the timer because we have 80 minutes for the test. So on the average, you want to only allocate 15 to 20 minutes per question. Time yourself. Okay, if you spend 20 minutes on a question and you're not done yet, just move on to the next one. Okay, don't spend too much time on a single question. Move on to the next one because who knows, the next one may be easier, at least from your perspective. When you're done with all 4 questions, then you go back to the one that you could not finish earlier and see if you can finish that one later. Okay, just general approach, which is not even specific to this class or Moodle. Just general approach of taking a test where you can change the order of answering the questions or come back to an earlier question. Some tests do not allow you to go back, so you have to use a different strategy in those cases. Do you guys take classes where you cannot go back to answer an earlier question? No? Okay. You do? Which class would that be? Calculus?
No, I've never had to take calculus one. Thank goodness. It was my other computer class.
Computer class.
cisp300 or cisp310.
CISC 300?
Yeah, 310.
Oh, 310.
Yeah.
Yeah, that's a class that's hard to teach.
Yeah.
Okay. So you basically do the homework assignment. You answer the question the same way as you do with your homework assignment. You just click the file, and depending on how you want to do it, you can open it directly from OpenOffice, or you can save it to your drive first, and then open it from your drive. And I'm just going to go through the motion. I'm not going to really, I will not do this, because we have done this one already. So I'll just, type some gibberish here. Oh, okay, you need to save it first. So save as. Now, when you save the file, I recommend that you save to your own flash drive, just so that you have a copy of your answer when you walk away from the exam. But you don't have to do that. Okay, it's just something that I recommend. Okay. And then the other thing is, when you save the document, you might want to change the name to something that is different from the original name, just so that you can tell that this is, this file contains the answer to a particular question. Okay, because I don't want people to get confused and turn in the same file that you download back to Moodle, because that would not contain your answer. So definitely try to name the file appropriately so that it reflects that this is actually the answer file, not the original question file. So now that I have saved it, I can just type some gibberish as my answer. Oh, gibberish, come on. It's not letting me, okay, there we go, gibberish, okay. Okay, the other thing is you definitely want to remember to save the file first. Okay, so you definitely want to save the file before you upload it. I would even go to the extent of closing the file first before you upload it, just to make sure that all the changes you have made to the document are saved before you turn it in. So now that I have, I'm done with this particular question, I can go through the upload interface, which is exactly the same as the homework assignment. You go through your folders, you locate a file, make sure, now in this case it is very clear that this is my answer file because the name of the file reflects that. So just click open, and you can see that the file name appears here. If you have another question and you are done with this part here, and you just click on the next question, it will turn it in for you. It will upload the file for you already. But if you want to be like absolutely sure that the file is uploaded correctly, you want to click Save Without Submitting. Okay, Save Without Submitting is basically just taking a snapshot of your answer. You can come back to this question later on and re-upload another file. In other words, this is not committing and say that this is my answer. I'm not going to change it later. This means that this is the answer up to this point. Later on, you can come back to this question and re-upload another file, an updated version of this file. Now, for whatever reason, if you accidentally click Submit All and Finish before you're actually done with the entire test, you don't have to panic because it does give you one option to get out before it will actually close the entire exam. So you definitely want to double check and make sure that are you ready to close the attempt. Closing the attempt means that you will not come back and change the answers anymore.
Just for that one question or for all the questions?
It is for all the questions. Okay, so you definitely don't want to click Submit All and Finish until you are ready to get out, leave the test.
So that screen right there, instead of having one, it's going to have 4 questions?
No, it's still the same exam. It's still the same examination or the same quiz. So that's why you definitely want to click Cancel unless you're ready to leave the lab at that point. Okay, are there any questions so far? So all the time, you might want to keep an eye on the title bar because it tells me that I have 1 hour and 13 minutes left. And this clock is not exactly accurate because it is based on the clock, the real-time clock of your PC or of the workstation, which can drift over time. Okay, and it can drift by at least 30 seconds. So this can be off by 30 seconds or so. You have to give yourself enough time to upload the file. Okay, so remember that part. Okay, so when this time is getting close to 0 minute and 0 seconds, you have to. I would recommend people to leave at least 30 seconds to upload the file. Just in case you encounter some problems during the upload process. Are there any questions at this point? Yep.
So we can't submit one file at a time?
Yes, you can.
Okay. Oh.
Yeah, every question is independent, so you can submit the file or the answer to each question individually. Okay, if you have multiple questions, there will be a link here to the next question, so you can jump around too. You can start with the last question if you want to. I mean, that's fine too. Okay. Any other questions about the test? No questions? If you have never been to room 152, you might want to go there today just to see how much desk space you have, because that will help determine how much paperwork and binders and whatnot you want to bring with you. You also want to take a look at the screen. I think those screens are almost exactly the same as this one here, which has a resolution of 1680 by 1080, which is a fairly high resolution. And remember, the first thing you might want to do is to change the resolution, because the default resolution is fairly low. Because some professor complained that he cannot see the little icons and double click on the icons. So the lab people have made the default resolution of the screen a little bit lower. But since most of you can read smaller fonts, you want to maximize the resolution so that your document can display more columns and more rows at the same time. That will help you during the test. Are there any questions? No questions? You guys are all prepared? We could have the exam today and you guys would be just fine with that? Excellent, that's what I want to hear. Okay, so when you're ready to test, when you're ready to end the test, you can click Submit All and Finish, and then click OK here. And after that, you cannot come back and change the answers anymore. And obviously, the score is all going to be 0 or a dash. because everything relies on me to grade it. There's nothing that can be automatically graded here. Okay. Any other questions? No other questions? So make sure you set your alarm clock on that day. Yes.
So when we say without submitting, we could come back to the questions?
Yes.
Okay.
Yeah, there will be like 4 or 5 questions. You can jump around too. You can just go to the last one, start on that one. The order does not matter. Any other questions? No other questions. Okay. All right. If there are no questions, we'll continue with where we left off last time.
Can you make sure that you upload those files?
In fact, I can do that now just to be sure.
It was the solution to the questions that we went over.
Okay, so that would be 0405.
Yeah.
Okay. And then to return to my normal role, turn on editing. That's not what I want to do. I want to choose that file. It doesn't let me do that. Yeah. Choose. There we go. It is now online. So that's one thing you can do is to save all the sample programs that we have talked about in the class and organize it in a folder structure that you feel comfortable with. Because otherwise you have full access to Moodle during the test, but you don't really remember on which day we talked about what example program and so on and so forth. So one thing you can do is to download all those zip files, unzip everything, look at all the sample programs, and rearrange the location of those sample programs so that you can find, oh, okay, I need to take a look at binary search again, for instance, okay, and you can locate it really quick, once you have your own files structure to locate, to put the files. Does that make sense? Okay, so you still need to study, even though the material is online, just so they can get to the material as quickly as you can. All right, any other questions? No other questions? All right, if there are no other questions, we go back to our types and records. I cannot talk about the solution of the records homework assignment just yet, because there will be one late submission that I will permit because of sickness. So that's why I cannot talk about the solution just yet. But since it's not in the test, I don't think it will impact your score at this point. All right, so we're still talking about types and records. Have we talked about an array of records? I think we did. We talked about how to find the maximum GPA or the student with the maximum GPA in the class.
Right, you said we'd talk more about it.
We'll talk more about it? Okay. So let's go ahead and start with that one. And I'm just wondering whether I should be using the file that I saved last time or start with a new one. Same one? Okay.
And you were kind of rushing to finish right before class.
You didn't finish it.
I did not finish it. Okay. All right. So that we have to first. I have to remember on which day we talked about that. Was it
Tuesday.
last Tuesday?
Yeah.
I mean this Tuesday?
Oh, wait, no.
Last Thursday.
Thursday.
Last Thursday?
31st.
Okay. 31st. array of records. That makes sense. That's the one?
Yep.
All right, let's go ahead and save it to today's folder. All right. So getting back to the code first, okay, getting back to the code just to get re-familiarized with the program itself. On line 1 to line 4, we have the definition of the record type. So once again, a record type in this case, is a template. It is your cookie cutter. Student started with the uppercase S is the name of the cookie cutter. So when you open up your kitchen drawer, you have all these different cookie cutters, and they can be identified by their names. In this case, this cookie cutter is called student, with the uppercase S. On line 2 and line 3, they basically show what are the components of a student record. In this case, we have two components. One component is the ID, which has to be an integer, and the other component is GPA, which is a number. Yep.
Could you identify a student just by their GPA?
No, you cannot. Because multiple students can have the same GPA.
Right. So
But I can identify a student by their ID because an ID is supposed to be unique within the district. Yep, this is just associating an ID with the GPA. So you have to look up based on the ID, but in this case, I only really care about the GPA because I want to find out who has the maximum GPA. And here we have a subroutine. The stub subroutine, which is basically just from line 6 to line 8. The first part we want to do is to, this is just a declaration so that we know that course as a variable is an array of 3 student records. On line 7, line 7 is a bogus subroutine that I don't even write. I'm just invoking that subroutine so that we can populate the content of the array that we call the course here. And then line 8 is the core of this particular exercise. I want to invoke a subroutine to find out what is the highest GPA of the entire class. And the subroutine is from line 10 all the way up to line 23. This is basically the same, almost exactly the same thing as find max index, except it's finding the maximum GPA in a class. And the portion that is important is this part here. We cannot compare x bracket m to x bracket I because what is x? X is a pass by reference parameter. It is an array of students. You cannot compare a student record to another student record because a student record has 2 items. Okay, one is the ID and the other one is the GPA. So what do you mean when you say I want to compare this student record to this student record here? Are you comparing by GPA or are you comparing by ID? Sometimes we want to compare by GPA, like in this case, but other times we want to compare by ID when I want to locate a particular student by ID. So that's why when you compare a record to another record, you always have to make sure that you're comparing a specific field of the record that can be compared. It has to be a number to another, to the same thing or something that is compatible from another record. Okay. The rest of the program is about the same, and then at the end here it will just print out the maximum GPA of the class. This one does not even try to identify who has the highest GPA because there can be multiple students with the highest GPA. It just identifies what is the highest GPA of the class. Are there any questions about the general approach of the algorithm? It's okay? All right. If that's okay, we'll go to the trace. And we have done some parts of the trace already. Basically, we assume that we are done with line 7, and by the time line 7 comes back, we have the array already populated. In this case, course will take up 6 columns because course has 3 student records. The first student record is taking up column D and column E, then column F and column G for the second record, and column H to column I for the last record. Each record is broken up into two different fields or two different properties. The first property is ID, and then the second property is the GPA, and that's why as an entire array, course takes up 6 columns. Are there any questions at this point about why we take up column D all the way to column I just for that one array? Questions? Okay. Now we move on to line 8 in the program. Line 8 is going to invoke find highest GPA, and we use course to specify X. So now we have to think about how are we going to set up the columns. First of all, should we use return line number or should we use return info? Return line number is fine because the subroutine does not have any return statement. If the subroutine has no return statement, there's no need to use return info. If you want to, you can do that too. It's just there's no need in this case to use return info. So instead of return info, we'll use return line number. Okay. Do you guys have any questions back there? Any questions? No? Okay. So the return line number would be the line that is logically following line 8. Line 8 is followed by line 9, which is the end of the subroutine. So the return line number is just line 9. Okay. So that part is pretty easy. And we need something else. We need 3 more things because we need X, which is the parameter passed by reference. In this case, what should we write in column K?
AKA columns D through I.
Exactly. AKA column D to column I, because I am using course to specify parameter X. Course is taking up column D to column I, and that's why X, which is passed by reference, is going to refer to the same columns. All right, but we have 2 other things that we need to set up. One is I, which is a local variable that we will use to go through the array. And then we also have M, which is another local variable that will store the index of the element that has the highest GPA. So these 2 as local variables will start with unknown values. One more time. Are we doing okay so far? Setting up the columns before we get into the subroutine? Yes? So far so good? Okay, let's go into the subroutine. The subroutine starts with line 14, so we'll go ahead and start execution on line 14. Line 14 doesn't really do anything that is exciting. It just initializes local variable M to a value of 0. Line 15, nothing exciting either. We're just initializing I to 1. And that's because on line 14, we are assuming the first element is the one that has the highest GPA. I can make that assumption because I haven't seen anything before this. So the first record that I see in the array, I can just make the assumption and say, well, let's say that this one has the highest GPA. I can fix that, I can correct it as I see more records in the array. I can start with 1 because I don't need to compare this record to itself. Because the assumption is the first record that I see in the array has the highest GPA. I don't need to re-examine the same record. I can start with the second one. So that's why I starts with 1 instead of 0. I can start with 0. It's just that you're going to waste 1 iteration in the loop if you did that. On line 16, we have to compare I to bar X bar. X is a reference to column D to column I. Column D to column I is an array that has 3 elements. In this case, bar X bar is the same as bar course bar, which is 3. I is 1. 1 is less than 3 is true. So on line 16, we'll say I is less than bar X bar is true. Then we move on to line 17. Line 17 is a little bit longer because it is testing X bracket M dot GPA to X bracket I dot GPA. And the question is that true or is that false? Okay, well, let's take a look. I know we cannot see M or I at this point. M is 0 and I is 1. So we are basically comparing, and X is effectively the same as course here. So we are comparing course bracket 0, which is m, dot GPA, which is 3, to x bracket I, which, and I is 1, so we are comparing to course bracket 1 dot GPA. Is the first one less than the second one?
No.
The answer is false. Okay, very good. Let's make this just wide enough for that. If the answer is false, I do not need to perform line 18, and we'll skip all the way to line 20. On line 20, I'm just incrementing I by 1, and I just need to line up the columns. So I goes from 1 to 2. When I'm done with line 20, I have to go back to the beginning of the while loop, or the pre-checking loop on line 16. On line 16, I will be comparing 2, because I has a value of 2 in this case, and I'm comparing that to the number of elements in X. X is a reference to an array that has 3 elements, so bar X bar is 3, and 2 is less than 3 is still true. Then we go to line 17. Line 17 is doing that comparison again. This time, x bracket m is still referring to course bracket 0, because we did not update m last time. But I is no longer 1. I is 2 at this point. So we are now comparing, and x is effectively the same as course. So we are comparing to course bracket 2.gpa, which has a value of 4. Are we doing okay so far?
So it's now true.
So this time it is true, because we are comparing 3 to 4. Are we doing okay so far on row 15 of the trace? It's okay? Okay. Well, since the condition is true on line 17, we are moving on to line 18, which is the conditional statement, which is the statement to execute when the condition is true. It's pretty easy. I just copy the value of I to m. I think that's row 16 of the trace. Yep.
Yes.
So I has a value of 2, m will now be updated to have exactly the same value. Then we go back to line 16, nope, we go to line 20. Line 20 is just incrementing I by 1. So I will be incremented by 1 from 2 to 3. And then we go back to the beginning of the loop. On line 16, I is 3, bar x bar is 3 as well. 3 is less than 3 is false. And that's why we get out of the loop and get to line 22. Line 22 is a print statement. All it wants to print is x bracket m dot GPA. M is 2 at this point, and x is a reference to column D to column I, which means it is effectively the same as course. Effectively, we are printing course open bracket to close bracket dot GPA, which in this case has a value of 4. So we just say it is printing a value of 4. After line 22, we get to line 23. Line 23 is the end of the subroutine. So what we need to do, just need to highlight the column, the row. Because now it's lost. It's row 20. And then we deallocate the columns at this point. And obviously, we have to look up return line number 2, just to know that we have to continue execution on line 9. And line 9 is over here, which is the end of the other subroutine. So now it is time to clean that one up too. And remember that we have to return to post after that. So we take these columns and indicate that they are now deallocated. And when we continue at post, that means we are all done. Are there any questions about this trace? It's tedious. Okay, it's tedious because we have an array of records. So in order to get to a particular number that we can use to compare, we have to first identify which array we are talking about, and then which element in the array, and then which part of that element we want to access. But other than that, this is, in terms of the logic, it is no more difficult or no more complex compared to find min index or find max index. Are we doing okay so far with this example, which illustrates how to use an array of records? Is that good? Okay. that is good. I'll save the file and then we'll close it. All right. Oh, here comes the other version of that. Okay, now we have closed everything. Okay. Now let's talk about something that is related to records, and I'll let you guys decide, whether what I'm about to do is not smart or smart. Okay, I don't need to look up the notes here because it's just going to be an example. All right, we'll just write a code. I'll do it inside, calc, even though I'm not going to trace this program, because it's a question not about whether the program can be traced or whether the program is doing something correctly. It has to do with, is this the best way of doing things or not? Okay, so I'll take a look. We'll do this. Okay, here is what I'm going to do. I will define, since we already know what is a student record, we'll just keep using it. Okay, we'll define the student record the same way as before. It has an ID, which is an integer. It has a GPA, which is a number. Okay, and record, like that. So this is the same as before, same as last time. I haven't changed the type of the record. And then what I'll do is I'll go ahead and write two subroutines. One to change the GPA, and the other one to return the value of a GPA of a particular record. Okay, and obviously that's not going to be very challenging. Okay, so the first one is called set GPA, which means we're going to change the value of the GPA. To do that, we need to pass by reference X, which is a student record. And we have to pass by value the actual GPA, which is a number. And then all we have to do is to say, X dot GPA equals to GPA, or gets the value of GPA. GPA. There we go. And sub. And we fix the indentation, and then we'll take a look at this one, because a certain part of it looks kind of confusing. Line 8 looks a little bit confusing. It looks confusing only because GPA is used on the left-hand side as well as on the right-hand side. But the two GPAs are different. Okay, they are completely different items. The one on the right-hand side, okay, this GPA here, refers to the parameter that is passed by value, which is called GPA. What about the other GPA? What about this one here? What is it identifying?
GPA of a student?
It's identifying the component of a student record that is also called GPA. And in this case, there's no conflict. There's no confusion whatsoever, because if you don't say X dot something, then GPA is not interpreted as a part of a record. It is just the name of a variable or a parameter. When you say X dot something, then that GPA cannot be referring to the parameter, because X dot means X apostrophe S. It is a possessive kind of thing. So we are actually talking about a component of X, and that GPA is fairly clear that it is the name of a component of X. So are there any questions about this line, line 8 of this code? Why, having GPA on both sides, should not be confusing? Is that okay?
So it's just they're not referring to the same thing. One is referring to a number, right? And the GPA on the right side, on the left side, is referring to a specific part of the student record.
Exactly. That's exactly it. Yep.
I'm not seeing where the assignment, what is being assigned.
The value of the parameter will be used to change a component of the record that is referred to by X.
So it will be defined in the invocation?
Yes. The invocation will say exactly which record and what, how we want to change the GPA. Okay, so that's one, and then we'll define another one which is even, less, complex. This is called get GPA. In other words, I'm just going to return the value of the GPA component of a student record. And since we don't want to copy too much stuff on the stack, I will still pass the parameter by reference, even though I'm not changing anything. But this time, I'm just returning the GPA component of X, which is a student record passed by reference into this subroutine, and define sub. All right, so now we have two subroutines like this, which doesn't seem to be very useful. Okay, we know what they do, but they don't seem to be very useful. Okay, and I'll just use a stub subroutine to show you how we can use these two subroutines, and then we'll do something else, and you can tell me, which way is better. So define stub, and this time I will have two local variables. The first local variable is Jack. Okay, so Jack is a student record, and the other one is Jill, which is also a student record. Okay, so just to illustrate, what I can do, with and without those subroutines, with Jack, what I'll do is I'll say I don't need to invoke, set GPA to change the GPA of Jack. I can say, Jack dot GPA gets a value of, I don't care, 2.4. Okay, and I don't need to use get GPA to actually get the GPA value of Jack. I can just say print, Jack.GPA, and that will display the value of the GPA of Jack on the screen. So I can say print Jack.GPA. That's done. Now with Jill, I'm going to do it a little bit differently. With Jill, I will do this instead. I will say invoke set GPA, and use Jill to specify parameter X, and then use Jill's GPA to specify her actual GPA. So let's say Jill has a GPA of 3.2, and I'll use 3.2 to pass to the parameter GPA of the subroutine. And then the other part is I want to print the GPA of Jill, but instead of printing Jill.GPA, I'm going to invoke the subroutine called getGPA instead. So that means if I want to print the value of Jill's GPA, I will say print invoke getGPA, and then I specify Jill as the parameter X, and whatever it returns, I will print. And define sub. Fix the indentations first. And what I want to do is to say, well, these two lines, line 17 and line 18 of this pseudocode, seems to be doing exactly what line 19 and line 20 are doing, just to a different record. So why do I even bother to use subroutines to change the GPA of a record and use another subroutine just to get to the GPA of a particular record? It doesn't seem to make sense. I mean, this seems like a lot of work for no reason at all. Is that making any sense to you? Why I might, why someone might use that argument and say, why do we even need the subroutines, get GPA and the subroutine, set and get GPA? Okay. So the main program is just going to invoke stub. If you want to trace the program, you can go ahead and trace it. But I think, do you guys want to trace this one? Because, I think it's relatively easy and we don't really need to do that. No? It's good, right? Okay. So the question is, why do we even bother to do something like this? Or the better question is, do people actually do something like that? And why, if people do that, why do they want to do it this way? So let's just kind of keep that question in our minds, okay, for the time being. And instead, we'll talk about televisions. Okay, we'll use an analogy that is completely unrelated to the homework assignment. I mean, not homework, but the topic that we have at hand here. How many people have seen a CRT-based, television? I think you guys are young, are old enough to have at least, seen a tube-based TV. Okay, 10 years from now, I'll probably have, the first generation of students who will ask me, what is a tube? Why do they call it YouTube? What is the tube of YouTube? I don't see any tire or anything like that, on YouTube. Why do they call it YouTube? Okay, so what is the basic technology behind a CRT or tube-based television? How do you see images on the screen? Yep.
Well, isn't it like it's an electron gun?
Yep.
That shoots an electron beam and paints an image on
The
pixels
phosphor.
row by row.
Yep. Mm-hmm.
And like 60 times a second or something. So
Yep.
you see.
Yep. Exactly. So the tube, if I look at the cross section of a tube, okay, this is actually about real size tube for a larger monitor. The back of this thing, without even having to explain what it is, well, let's go ahead and explain a little bit here. Okay, it has an anode. Let's see. No, this is a cathode first. So it has a cathode. The cathode means it is it emits electrons. Okay, it's a highly charged thing that has a lot of electrons that are ready to go at any time because it's a high voltage. This entire thing is vacuum. There's no air inside the tube. And there's a little aperture here. Okay, the aperture is positively charged with a high voltage. So there's a huge voltage between the cathode and the gate here. And electrons likes to go from where to where? From a negatively charged place to a positively charged place. So all these electrons, are saying, "Oh, I want to go," and it will go. But instead of going and landing on this plate here, it will shoot through because it's just an aperture. Okay, so this part here is called the electron gun. Okay, and by changing the voltage between the cathode and this positively charged gate, you can change the speed of the electron. The higher the voltage, the electron will shoot out faster. The slower the voltage, the electron will come out slower. That's how you can control the speed of the electron. And then after this, we have some coils, okay, magnetic coils, one arranged like this and the other one arranged like this, so that because any charged object that is in flight you can change its path by changing a magnetic field around it. Okay, you have to take physics, to really understand that part. But the electromagnets can be used to deflect the electron. So you can now deflect it to go high, you can deflect it to go left, to go right, and so on and so forth. So by changing the magnetic field, you can now change which way you want to direct the electron. Is that okay so far? Can you guys see electrons? I cannot see electrons, okay? But you can see photons. So an electron will basically hit the inner surface of the tube, which is laid, which is covered by phosphorus material, which is luminescence material. When they are struck by electron, they will emit visible light. So when an electron hits this place here, then it will bling. You see, a very short flicker of light. Okay, but do you see flickers of little spots of lights when you watch TV using a tube? No, you see real images and whatnot. So the trick is you have to shoot the electrons really fast, and instead of seeing individual electrons, it's kind of like a machine gun. Okay, it's spraying horizontally, and then it moves down a little bit, and then it sprays again, and it moves down horizontally, and then it sprays again. So that way, to your eyes, in other words, if you look at the front of a CRT, it's spraying electrons really fast this way, and then it moves out and then sprays really fast this way. So it's doing this really, really fast. So to your eyes, it seems like it's just a stationary image. Okay, so that's the basic of how a tube-based television works. Okay, having said all this stuff here, there has to be a reason, right? Did you have to take a physics class? Physics, I don't know what this is. When do they start to talk about electromagnetics in physics? 121. This is probably a little more than just 121. 421. Okay, so it's a 400 level class, which is the highest level of classes that a community college can offer. So the question is, did you have to take physics 421 before you can know how to use a television? No, not really, right? I mean, so when your picture is too dim, okay, let's say you were watching TV and it's really bright outside, and you want to turn up the brightness of the image. Did you have to open up the back of the television, take out your screwdriver and try to tweak some settings to change the voltage between the cathode, which has a E, and the positive gate? Did you have to tweak that and hope that you don't get zapped in the process? No. Why not? I mean, but this is exactly how it works. Okay, well, this is one technology. What about LCD TVs, LCD screens? How does that work? Okay, LCD works a little bit differently. You basically have some sort of light source, either fluorescent or LED now these days, as a light source. So the light source will first go through what we call a polarizer. Okay, so here's a polarizer. when you emit light, when they oscillate, they have an axis of oscillation. So it can either oscillate like this, which is perpendicular to the plane is perpendicular to the floor, or they can oscillate like this, or they can oscillate to any particular axis. What the polarizer does is only allowing certain orientations to go through. So right here you lose half of the light already. And then what we do, after that is an LCD device. Okay, LCD stands for liquid crystal display. And the way it works is you plate a very thin layer of conductive material that is invisible to the eyes, across the two plates here. And then you have, crystals, that are suspended in liquid. And normally they are not aligned in any way. They're just randomly aligned, which means they will block some light, but they won't. They're not selective. They're just stopping some light from going through the device. But it's not selective. It just says, okay, whatever goes through will take this percentage off. When you apply a voltage across these two plates, then the crystal will align. They will suddenly go like, oh, okay, we have to align in a particular way. When they align, then they will only take out the light waves coming in when they're only with a certain axis. Now, since this one is already subtracting all the light from a particular orientation, if the liquid crystal display layer is taking out the other ones, then you see a dark pixel because no light is going through these two particular thing. If this is all randomized, then you see a white pixel. And that's why LCD is not very efficient. Because from here all the way up to here, if you look at the screen from here, when you look at a white pixel, which is basically letting out as much light as possible from the backlight, it is only about 10% of the intensity of the backlight. What happened to the other 90%?
You have taken them forward.
The other 90% got blocked here or here, even when your pixel is supposed to be 100% brightness. Okay? Is that okay so far? Just the basic mechanism of how this works. Did you have to get a degree in material science before you can change the contrast or the brightness of your LCD TV? No? What do you do?
Go to the menus.
OSD, right? On-screen display. And the same thing with this TV here. When you use a plasma TV, do you think you have to understand the basic mechanism of a plasma TV before you can use it? What about OLED, organic LED? Same thing. Okay, so why don't we have to understand all that stuff? What do you use?
Because there's a mechanism to do it.
Because, sorry, say that again?
There's already a mechanism to do it.
A mechanism to do it. What mechanism are you referring to?
Well, whatever the on-screen display is doing, it's been defined ahead of time.
You're talking about your remote control, aren't you? Okay, so your remote control, this is a remote control of a projection screen, so it's not really quite the same as your TV, but it has all the same controls. If I go to, let's say, menu, I can navigate to, okay, I don't exactly know how to make this work. Nope, that's not it. Okay, let's do it again. Menu, come on. Okay. There's a little cursor key here, which I think is, oh, there's a click button. No. Oh, I see the cursor keys now. Okay, there we go. So I can just go to bright, to control the brightness. I can go to contrast to control the contrast. I don't have to understand a single thing about how overhead projectors work. Okay, I don't have to care. It can be LCD based, it can be DLP based. The light source can be halogen based, it can be LED based. I don't really care. I don't have to care because I have this. I have my remote control. Okay, when they change this display, let's say 2 years from now to some super duper new technology, as long as I know how to get to this screen, I'll be fine. Is that making any sense so far? Is that a good thing or a bad thing? Or do you think that, tech, you really should know the technology behind the whole thing and have a screwdriver handy at all times so that when you need to tweak something, you have to open the case and start to tweak, something on the circuit board itself?
It's a good thing.
It's a good thing. This is a good thing, okay? In terms of the concept of a remote control, it is an abstraction, okay? It's an abstraction of whatever you want to use a remote control to control. What is abstract? What does abstraction mean? Losing details. Okay? When you understand something that is abstract, that means you're losing all the details related to things that are relatively useless or irrelevant to you at the time. Okay? Now, how does that relate to our program? The one program that we have been talking about at this point.
Subroutine is an abstraction of what you're actually doing, and the other method is the actual
Exactly. Okay? Exactly. Okay, so let's go back to this sample to this program here. When I do something like this, okay, I can actually change the font size this time because I'm not tracing it. When we look at line 17, line 17 is equivalent of opening up a television and start tweaking the internal circuits to get something done, because this is pretty much as low level as it gets. Okay, accessing a particular element of the record of Jack and changing it to a particular value. This is because if I change the implementation of a student record, this has to change as well. Okay, and the same thing applies to line 18. Because line 18 also relies on the definition of a student record, because it is accessing an element of the record directly. What about when I access, when I deal with the Jill's record? When I deal with Jill's record, it is one level more abstract. Okay. Now, what do you mean by it's one level more abstract? I mean, I still have to specify Jill. I still have to specify the GPA, but I don't have to say that Jill as a record has a field or a component called GPA anymore. Okay? And for the same reason, when I try to get the GPA of Jill, I'm just specifying whatever you have to do, subroutine get GPA, I want to get the GPA of this record that I call Jill. But I don't need to know that GPA is a component that is already stored in the student record, in this case, for Jill. Is that making any sense so far? But tech, who wants to change the implementation of a student record? I want to. Okay? Because storing a GPA of a student is not exactly the smartest thing to do. Because the one thing you might want to do is to store the individual point values of all the tests, instead of the final GPA. So this way you can recalculate the GPA from the score of each individual component. Well, if I change the implementation here, I will also have to change everything that looks like this, because if I try to access GPA directly, then all of those things don't work anymore. None of that is going to work. Is that making any sense? Okay, let's save this program, and I'll use another program which is even more realistic to present this point. Okay, so this one obviously is going to call Jack and Jill. Okay, the next one is more realistic because it is actually a program kind of thing. This one has to do with coordinates. Okay, record. I'll just specify a point. Okay? How do I want to store a point? How do I want to represent the coordinate of a point in a 2D space? What do you think is the best way to do it?
X and Y axis.
Sorry, go ahead.
Two numbers.
Two numbers, okay, and
X and Y axis.
X and Y. Okay, very good. So we'll use X and Y to represent a point. And let's just say that this is also using a raster-based display, which means we do have finite dots. So X is an integer, Y is an integer, and record. Okay, excellent. This is pretty easy. Okay, So if I want to access, where a particular point is, I can define something like this. Okay, define sub get point x, and I will pass by reference a point of the type point. P is a parameter of the type point, and I can return p dot x and define sub, and I will define another one to get to y. Okay, define point y by reference p, same thing here, and we just return p dot y and define sub. Fix the indentations. And now we have two subroutines, just to return the values, which is the x and the y of a particular point. Okay, let's see, what we can do with this. Okay, so we define a stub function just like before, and this time we'll just define a single point. We'll say this is a local variable, it's a dot, and a dot is of the type point. If I want to initialize, where that dot is appearing, I can, I need something else. Okay, let's just say that I have a way to set the coordinate of this point here. If I want to display, this dot or find out where it is on the screen, I can just, I can say invoke get point x, and then I will pass parameter dot to parameter p, and so on and so forth, just to get to the x coordinate of a dot. Okay. Is that making any sense so far? Just making use of the subroutines. But this seems like a lot of work that does not have any payback. Okay, because I'm defining the subroutine and doing this is a whole lot more typing than just saying dot dot x, right? So what is the value? How does this relate to the remote control versus the actual technology behind the displays? How does this relate to that? Well, are you guys sure that x and y are really the best way to represent the location of a dot? Let's think about it. On a screen like this, absolutely. On a screen like your cell phone, absolutely. What about not on the screen anymore? The tech, what kind of display is not raster based? I mean, raster based means it is XY based, and it has finite dots. One dot is a pixel, so that's raster based. All cameras are like that. Okay, let's think about a bicycle. Okay, so I'm changing this seemingly to an unrelated direction. So here's a bicycle with two wheels. Okay, and there are tons of bicycles in Davis. All right. And this is the spoke. These are the spokes of a bicycle tire. Okay? So let me ask you this question. What if I put a bar of LEDs on one of the spokes? Okay? LEDs are light emitting diodes, so I can turn it on and turn it off. If I turn on the LEDs and have this wheel to spin, you will see a circle. Okay? What if I make these LEDs blink as the bicycle wheel turns? Okay, they'll be on and off, right? But if I control the on and off of these LEDs on just one single bar, and let's say this wheel is turning relatively fast, I can actually control the image that would be displayed by the bicycle tires, a bicycle wheel. Okay, has anyone seen anything like that? Kind of like a fancy display using bicycle wheels. Yep.
I think they've got a 3D image display for like MRIs or something like that.
I'm not sure about MRI. But I've seen something that's really fun.
Some kind of scan, but like they have like a spinning mirror that will.
Right. Yeah, spinning mirrors. But spinning mirrors typically are raster based too. That's how your laser printer work. Okay, there's a spinning mirror, but the spinning mirror is still it's basically converting a stationary laser emitting diode, and so that when the mirror spins, it will land on a linear part of the line. So by controlling the on and off of the laser diode, now you can specify where the dots are supposed to be when the toner lands on the polarized portion of the paper. So what I want to do is to look up Pac-Man, bicycle, and I think that should be enough to find it. Animated Pac-Man bicycle wheels. That's what I want. Don't necessarily want it on my bicycle, but okay, so here's a picture. Not sure if, oh, it's an animated GIF. Perfect. That's exactly what I want. Let me turn off this, all the lights here so you can see what I'm talking about. Can you guys see the bicycle that is, upside down? It's, just, put upside down here. This is the head of the bicycle, and that's the seat of the bicycle, just faintly, maybe. Okay. Okay, both of these wheels are turning at a relatively high speed, and by controlling, okay, each one has one single bar or a few bars of LEDs. By controlling the on and the off and the timing of the on-off of the LEDs, it can, because of the persistence of vision of the human eye, you can actually display images like that. Okay, which is kind of fun. Some of you probably will transfer to UC Davis. So when you get to UC Davis, you can try to make your own bicycle light so that you can impress people with Pac-Man versus the Ghost or something even more exciting. But the whole point is, what do you think is the proper what is the native coordinate system of something like this? It's not X and Y anymore.
0 to 360.
It will be the angle versus which LED on the bar, right? Okay, so that means sometimes using X and Y is not necessarily the best way to represent where a dot is. Okay, if I go back to my example, just here, that means all this stuff here may have to change because in another type of situation, I may not want to use X and Y to represent a point. Instead, I want to use R, which stands for radius, and also A, which stands for angle, to represent a particular point. Because it is the rotation. Okay, when I use that notation, that means I'm looking at a circle, and this is 0 degrees, and I can now specify what is the angle. This is A, the angle. And then I can specify the radius, which is the distance from the center of rotation to the spot that I want to control. This is called a polar coordinate system. Okay? All right. So if I change it to the radius and angle, sometimes I might still want to specify a point by using X and Y. Because when I display the Pac-Man thing here, I still want to specify, in 2D in normal XY coordinates. I may digitize, these images from a raster type of display, and I have to convert it into the polar coordinate. So sometimes I need a conversion between the two. So in this case, if I need to do a conversion between the two, I would need something like this. I would need to define another subroutine, which is to set the x coordinate of a point. In this case, I can set both the x and the y. And in this case, I will still be passing the point by reference, which is a point. But this time, the point is representing everything in polar coordinates. I will pass by value, the x value, which is going to be an integer. And I'll be passing in the y, which is also an integer. Now, before, it's easy. Because before I can just say p.x gets x, p.y gets y, and I'm all done. Because in the previous version I do have x and y as the individual components of a point. I don't have that anymore. Instead, this time I have p.a, which is the angle, and then we have p.r, which is the radius. How do I set the angle in this case? Okay, let me redraw this picture. How many people have taken trig already? Is that a high school thing? Yeah? Okay. Sophomore year. Okay. All right. So, given that this is R, this is A, how do I get to the x and the y of this dot here? What is x? X is from the center here, center of rotation, to the x, to the horizontal displacement from the center of this dot here. I know r already. R and a are given.
R sine A.
This will be r sine a, exactly. Okay. So in this case, I take it back. It's the other way. It's the other one. I give you x and y. I want to find out what is a. Okay. It's
It's inverse sine.
it is the
And
arc
we're-
tangent of
Y over X.
y over x. Now, obviously, this is not checking for the case where x is 0, because when x is 0, x divided by y divided by x is undefined. So the subroutine really needs to check for a little bit more than what we talk about here. But just for the point of this argument, it's fine. How about r? If I tell you what is x and what is y, can I find out what is r? That's pretty easy, right? That's just square root of x times x plus y times y. X squared and plus y squared, and then you take the square root of the whole thing. And define sub. So that means if I had a subroutine called set point xy, all I have to do is to change one single subroutine, and then the rest of the program is fine. As long as people only use set point xy before I change the representation of a point up there. Is that making any sense? This is equivalent of saying that, okay, let's assume that everyone is already proficient with using a remote control. And to be even more specific, let's just say that everyone is trained to use a Proxima specific projector, and they never changed the menu system. Okay, the menu system always looks like this regardless of the technology. Okay, so this is our subroutine. This is our set point xy, get point x, get point y, and so on and so forth. It defines the buttons on the remote control as well as what each button is going to do when you press it. Changing the representation of the record is changing the projector itself, using different technologies, using more efficient technologies, and so on and so forth. I don't want any change inside that box to affect anything that is over here on the remote control or on the on-screen display here. That's why we want to use subroutines all the time. When you want to get something from a record, use a subroutine. When you want to change something in a record, use a subroutine. Because that way, if you want to change the implementation of the subroutine later, you only have to change the abstraction subroutines, and the rest of the program stays intact. Okay? So that's the main point that I'm making today. For the next class, I will have even more examples just to illustrate that point. Yep.
So we don't actually change the record, we change the subroutines that have to do with it?
You have to change the subroutine, but hopefully you only have about 10 subroutines that you have to change instead of thousands and thousands of references to the actual component inside of the record.
Yeah.